Hello. Today we are going to see what deadlock means and what are the prevention techniques and methods we will use while solving a deadlock. First, we'll see what deadlock. So deadlock, it is a set of blocked processes, each holding a resource and waiting to acquire a resource held by another process. So think that there are two processes, uh, uh, P0 and P1, and each are holding one tape drive. So there are two tape drives and each is holding one tape drive and it is waiting for another one. Like the process P0 and P1 are waiting for one another to release it. So think about the example where uh, two students require blue and red color pen, and each are holding, one student holds blue color and another student holds red color, but one student, he needs red color pen, wants another to release a blue color pen. So in the same way, so deadlock occurs. So if you see the second example, so the traffic jam system where all the cars are at the this circle where all try to move. So they cannot move and they will suffer here. So they will suffer here only. So that is what the deadlock has occurred. So how we can solve these kind of problems? So the system for deadlock, so we'll categorize as resources. Resources can be anything like CPU cycles, memory, IO devices, or whatever. So those resources needed for any process to execute. So they take that resource uh, and do whatever uh, thing they want. So each process or resources have instances. So it can be given as WI. So how the process utilize those resources? It might request a resource, or after requesting, the resource is granted. It can use the resource. After operating on that resource, it can release a resource. So it will happen as a three process: request, use, and release. Suppose there is a printer, 10 computers. So all the 10 computers want to print. So what will happen is the computer which requests first will be given a chance and it will use, means it will print, then it will release that resource. Then it will go on uh, giving a permission to second computer which has requested. So there is only one instance. So resource is like printer. So how many instances? Only one printer. So it might be resource printer is printer. There might be a two instances, means two printers available. Okay. So this is how usually we will follow. Then how we can characterize a deadlock? So usually deadlock occurs when there are these four conditions which occur in a system simultaneously. So if you take any system, we have to check for these four conditions. That is mutual exclusion. Mutual exclusion is nothing but only one process at a time can use a resources. Then hold and wait. So hold and wait is a process is holding one resource and it is acquiring additional resource held by other process. So we'll see with the example how these characterization is given. Then third one is no preemption, means process uh, which acquired that resource, it can voluntarily release. So a resource can be released only voluntarily by the resources, uh, uh, voluntarily by the process after the process has completed its task. Then the last one is circular wait. So circular wait where uh, if you see that a set of processes like P0 to P1, and at last there is a process called as P0, means they are waiting in circular fashion, means in the same way where we have taken uh, the example two students. So in the same way, there are n number of processes, but they are waiting in circular fashion. Means the at last the last process is again waiting for the first process to release the resources. So it is the circular wait. Okay, so we have to check these four conditions in our system and uh, see that if the all four conditions occur in the system, we will definitely tell the system is in deadlock state. Then we have to use some methods or techniques where a deadlock can be avoided. So we'll see how for any system we will uh, have a resource allocation graph. So resource allocation graph is nothing but this is the graph. We know what graph means. It's a set of vertices and edges. So we'll take the processes and the resources, and we'll see uh, how it can be represented using at that graph. So resource allocation graph will give us how the resources are allocated for each process and which resource it is actually requesting through an edge. So there are uh, uh, the V is given as partitioned into two types, like process means these are the vertex. So process, it consists of all the process in the system represented as P. Then there is a resource R. So it is also given as a vertex, but it is represented as R. So R is nothing but resources of the system. Then there can be a two edges, that is directed edge. Requesting edge is given from process to resource. Then assignment edge is directed from resource to process. Then what do you mean by requesting edge? Request is nothing but process want means it is requesting a resource. Assignment edge is nothing but already the resource is allocated for your process. So this is how resource allocation graph is represented. So for any system, we have to draw resource allocation graph and check whether these previous four conditions exist in the system. If they exist, we will tell the system is in deadlock state. Then next, how we can represent. So a process is represented as vertex. Then resource of four types means instances. So this is the resource, four instances. Then PI request instance of RJ. How it can give given is this. There are four types of instances means resource. So it is requesting how many instance it wants. So it can instance two. So it needs two resource. So two resources allocated since it has four. Then PI is holding. Holding means what? The see the edge. It is represented from the resource to your process. So this is what we will represent means when we draw the resource allocation graph for any process. So we will represent it as this. So before going to how the resource allocation graph, for example, so we have to first see uh, these four conditions: mutual exclusion, hold and wait, no preemption, and circular wait. Okay, so we'll see that example how it is represented for resource allocation graph. So RAG in short form. See, the process is represented as vertexes, then resource as R1, R3, R2, and R4. So these are the instances, one and two instances, then one instance of resource one. So process one, see the direction. So it is allocated to process one. Then process one is requesting the resource R1. So it is requesting. So in the same way, resource 4 is neither no process is requesting a resource 4 or it has been allocated. So R3, it is allocated for process 3. So this is how our system is represented. It is how it is represented in our uh, by using a resource allocation graph. Okay, so we'll see in the next video how we can see deadlock occurs and not. Okay, thank you.